You've already learned a few multiplication problem exponents, but today we're going to focus on a couple more of them. So like we did the first time when we talked about negative exponents, and I would like you to look for a little pattern. So this slide's going to look pretty overwhelming, but I want to go through a little bit of it together. So first of all, if I asked you, hey, what does 3 to the 6th squared mean? I hope you would notice that that just meant 3 to the 6th times 3 to the 6th. And based on what we learned the other day, we can keep the base and add the exponents. 3 to the 6th plus 6. We're doing that 2 times, which means it's 3 to the 6th times 2, which means that simplifies to 3 to the 12th. Okay? Let's look. You can pause and try all of these if you want. I'm going to work out maybe the last one for you. So c to the third to the 4th power means c to the third times c to the third times c to the third times c to the third. Okay, times itself 4 times. So again, we're going to add c to the 3 plus 3 plus 3 plus 3, which you might notice is c to the 3 times 4, which equals c to the 12th. Okay, it doesn't always equal to c to the 12th, but I want you to look and see if you see a pattern. Okay, and you can fill in the rest. If you got it, this one would have been to the 12th. So that one would be to the 28th. Number 4 would have been to the 6th, and number 5 would have been to the 12th. Okay? I hope you see a pattern happening here. I hope you're noticing that you're keeping that base the same, but this time when you're taking that power to a power, the shortcut, instead of writing it all out, is that you can just multiply those two exponents. So if we're trying to simplify 8 to the 6th, that whole thing to the third, our shortcut can just be 8 to the 6th times 3, which is going to give us 8 to the 18th. All right, you may have started to formalize your rule, and here it is. For every non-zero number a, and integers m and n, a to the mth power, the whole thing, the quantity of that, to the nth power equals a to the m times n. Okay, so let's try a few. I want you to try these on your own if at all possible, but then I'm going to work them out and you can see if you're getting them right. So the first one, a to the third to the 4th power, so our shortcut is a to the 3 times 4, and that should give us a to the 12th. Okay. This one's a little harder because I need to work with some order of operations. So obviously I want to do exponents first, and I'm going to take b to the third to the negative second first. So b to the 3 times negative 2, that should be b to the negative 6. And I'm still multiplying that by b squared. Okay, this is my rule from yesterday, so it's b squared times b to the negative 6. I'm going to keep the base. I'm going to add the exponents. So I get b to the negative 4, but oh wait, that's not a final answer because I can't have a negative exponent in my final answer. So remember, this is the reciprocal of b to the 4th. So 1 over b to the 4th, that's okay to write. All right, I'm going to give you a little challenge and see if you can try it. Can you simplify the quantity 2n cubed, that whole thing to the third? And my tip is try expanding it out. Okay, so pause, make sure you're trying this, and I'll see if you got it right, or you'll check by watching what I do. Okay, so one thing, 2n to the third, that means 2n to the third, times 2n to the third, times 2n to the third. And remember how we talked about order doesn't matter. This is multiplying in any such way. This is all just multiplying. So if I want, I can multiply 2 by 2 by 2 together, and I can multiply n to the third times n to the third times n to the third together. Just multiply this all out. So 2 times 2 times 2 is 8, and this is n to the 9th. What I hope you had to notice is that it's not just 2n to the 9th. This power of 3, it has power over the 2 as well as over to the n to the third. It works pretty similar to the distributive property. This is called raising a product to a power. So we're having something that we're multiplying in there and we're raising it to a power. So for every non-zero number a and b, an integer n, the quantity ab to the n equals a to the n times b to the n. So kind of like I showed you before, you're kind of distributing. That n is being multiplied by each part because when we write it all out, each part is getting written out n times. So here's a typical problem. Simplify the quantity 4x cubed squared. Okay, and if you don't want to write it out, then you need to remember that the square needs to go to each piece. So here we're doing 4 squared times x cubed squared. And what I know about 4 squared equals 16. X cubed squared, that means x cubed times x cubed, it is x to the 6th. And that's the simplified form. If I want to do 4x cubed squared, and I would get the same answer if I had just multiplied out 4x cubed times 4x cubed. You can see I could still get 16x to the 6th. All right, this one's more complicated, and I really want you to try it on your own because this is a fun topic. It's trying to simplify it all out in a manner that makes good sense, but it can get pretty tricky too, and it's hard to double check your work. So this is a good experience while I'm going to show you your answer. Okay, so we're going to look at this a piece at a time. The first thing, this is to the second power. I'm going to distribute that second power to everything in there. So it's going to be 4 to the second times x squared times y cubed squared times x cubed to the negative 3. So I'm going to simplify this already. That means x to the negative 9. Okay, and then I'm going to keep going. I know what this is. Y cubed, that whole thing squared, is y to the 6th. And I know this is 16. So I've got 16x squared, y to the 6th, x to the negative 9. I am getting close. But I still have some x's, multiple x's. So x squared, x to the negative 9. That wasn't all my ex-boyfriends. Here's the x right there. So 16 x squared times x to the negative 9, that's going to be x to the negative 7 and y to the 6th. Okay. Oh yes, we are very close to the end here. The only problem is I have a negative exponent. I don't want that in my answer. So I'm going to start writing my fraction. 16 has a positive exponent of 1. It stays on top. X to the negative 7. Oh, reciprocal, reciprocal, reciprocal. Let's put x to the 7th on the bottom. Y to the 6th, that looks all right. It's positive. It can stay on the top. This entire expression simplifies to 16 y to the 6th all over x to the 7th. All right, and then this last problem, word problem. An object has a mass of 10 squared kilograms. The expression 10 squared times the quantity of 3 times 10 to the 8 squared describes the amount of resting energy in joules that the object contains. And your job is to simplify the expression. So we are trying to take this entire expression, 10 squared times 3 times 10 to the 8th squared. Okay, so I'm going to have to deal with the second part first in distributing that power to everything inside. Okay, so I got to remember because it's a product to a power, so I need to do that each part. So I have 3 squared. Okay, so when I've done that, I have 3 squared times 10 to the 8th squared, and I'm still multiplying this entire thing by 10 squared. All right, so we'll do what we can. I know that 3 squared is 9, and I know that 10 to the 8th squared is 10 to the 16th. So now I have 10 squared times 9 times 10 to the 16th. All right, and I'm going to take my powers of 10 and multiply them together. So 10 squared times 10 to the 16th, that gives me 10 to the 18th times 9. And this is awesome because this is already in scientific notation, which is probably the form I want it in. And it looks like it says this is the amount of energy in joules, so I'll label that 9 times 10 to the 18th joules. All right. I hope that you can kind of enjoy manipulating these expressions and get them into simple form, and we will practice more. Have a great weekend.